Hello everyone, this is the last class of the semester. I hope this course has been helpful to you in some way. In this session, I will explain the harvesting and the processing of cannabis fibers. Cannabis bark is easy to separate from the woody core. The exposed woody core is named hud or a sheath and is composed of secondary xylem. The best fibers are derived from the phloem in the stalk, so it's also called phloem fiber. The fibers are among the Earth's longest natural fibers and are also rich in cellulose. If you peel off the green layer of the cannabis stem, you will find white thread-like structures inside, which are the best fibers shown in this slide. White hud of cannabis stem is composed of secondary xylem. The right micrograph is the transverse section of a cannabis stem. The phloem fibers support the conductive cells of the phloem and provide strength to the stem. The phloem fibers are packaged within the phloem in bundles of long cells arranged along the length of the stem. A matrix of lignin, actin, and other materials bind these fibers together tightly. A vascular bundle consists of a xylem for water transport and a phloem for nutrient transport. These are responsible for the plant's structural integrity. Cannabis fibers are classified into primary and secondary fibers depending on the development. Primary fibers are located on the outer part of the stem, while secondary fibers are located on the inner part of the stem. Primary fibers are long and soft fibers and called best fibers, while secondary fibers are short and hard fibers. Cannabis fiber is so durable that people use it for clothing and many other purposes. Cannabis fiber has many advantages and unique properties. The fiber has low lignin contents and it naturally resists bacteria, fungi, and insects based on compounds like alkaloid, flavonoids, and saponins, many of which serve protective functions in the living plant. In addition, cannabis fiber has excellent properties such as thermal and sound insulation, UV blocking, and oil absorbency. Cannabis paper can be recycled up to 8 times compared to just 3 times for paper made from wood pulp. Compared to its wood pulp counterpart, paper from cannabis fibers resists decomposition and does not yellow or brown with age. The lignin content of cannabis fiber is 4%, which is extremely lower than that of general wood pulp, 17 to 35%. Cannabis fiber can significantly reduce the use of sulfurous acid to dissolve lignin in the pulping stage. Afterwards, These are rinsed with water, and because the sulfuric acid content is low, it is possible to wash them off completely. That is why cannabis papers can be preserved for a longer period, so it is an eco-friendly material. Next, let's learn about fiber harvesting. Please look at the first picture. Densely sowing the seed is important for cultivation of fiber production because the fibers become thinner and longer when plants are grown closely. Cannabis grown for fiber is typically harvested when the plants reach full height between early bloom and early seed set around 70 to 90 days after planting. Harvesting during this period ensures durable, high-quality fibers. After cutting, the stalks are laid in rows in the field to begin drying. The goal is to reduce stalk moisture to below 15%. Cannabis stems are harvested. They are dried in the field for 2 to 3 weeks. This first step is retting. Retting is a microbial process that breaks the chemical bonds that hold the stem together and allows the separation of the best fibers from the woody core. Delayed harvesting can increase lignin content and reduce the quality. Fiber harvesting in cannabis involves a highly mechanized process focused on collecting the stalks, which then undergo retting and decortication to separate the valuable best and hard fibers. Fiber harvesting involves cutting stems at early flowering stage and probably retting and processing them. The first step is cutting the stems, which can be done manually or by harvester combine. The next step is windrowing, which stems are laid in rows to promote uniform retting. You can see a combine is harvesting cannabis plants. Next to it, you can see cut stalks are laid in the field for retting purpose called windrowing. Cannabis retting is a crucial natural process using microbes and moisture to break down pectin and lignin, separating strong outer fibers from the woody inner core for textiles, construction, and other materials. The three methods are field retting, which is leaving stalks in the field to decompose naturally over weeks. And the second method is water retting, submerging stalks in hot water for a more uniform but labor-intensive result. With both methods rely on microorganisms to rot away the binding tissues. The last method is enzymatic retting, but it is too expensive. Therefore, it can only be used in special cases. Cannabis stems are harvested. They are dried in the field. This first step is retting. Retting is a microbial process that breaks the chemical bonds that hold the stem together and allows the separation of the best fibers from the woody core. Scotching is the next mechanical process, separating some of the remaining hairs from the best fiber. Heckling is conducted in which the fibers are combed to remove any remaining woody particles. After the heckling process, the long and short fibers are separated from each other. Each type of fiber has its own uses in industry. Spinning is the process of twisting and drawing out the long fibers to make them into a smooth and continuous yarn. Weaving is the last step to make fabrics. This slide shows how the fibers change through the process. After heckling process, two sorts of fibers are separated into long fibers and short fibers. The long fibers, called silver, are used in the textile industry through the spinning and the weaving processes, while the short fibers, called tow, are used in paper industry and the composite industry. This slide shows the photographs illustrating the entire process of utilizing best fibers in the textile industry on a factory scale. Best fibers of cannabis are processed and utilized in many industries. It's expected that the use of these fibers will expand to even more diverse fields in the future. All right, everyone, I appreciate your participation in this course. I hope these lectures have been at least somewhat helpful in expanding your knowledge of cannabis. Thank you. Bye.